Alright, the first thing we're going to do today here is we are going to do the law of sines, law of cosines method of figuring out the um, resultant. So the first thing we need to do here is draw out our two vectors. And our first vector is 125 miles per hour at 35 degrees. The other one is 20 miles per hour at 106 degrees. Again, I'm going to use pink for straight north, just like the previous video that I did. We know that the first one is at 35 degrees. That means that it's about, not quite there, but we know this one is 35 degrees. From north all the way to that line is 35 degrees. And we know this line is 125 miles per hour. We know then that the blue one also is just past 90. We know 90 is the directly straight east one. So we know this one is from all the way in here to all the way over 106 degrees and 20 miles per hour. So the next thing that we need to do here is go in and draw in the entire parallelogram, because with the law of sines, law of cosines method, we're always dealing with parallelograms. So we have one that's going up this way. We now need to draw one at the bottom that's approximately parallel. We need to draw one at the top that, and more than just approximately parallel, we want to try to make it as much parallel as possible. So this is now a parallelogram. This blue side is parallel, means it never is going to intersect this bottom blue side here. And the two black sides are also parallel, will never intersect. So I'm going to put it in green here. Our resultant goes from the tails all the way straight across to the tips. Straight diagonal, that is our resultant. That is R. In a minute here I'm going to redraw these so it looks a little bit nicer. But both of the black lines are 125 miles per hour, and both of the blue lines are 20 miles per hour. The green line we don't know yet. So the next thing we need to do is we need to find this line, this angle right down here. Theta is always going to be at the tail of the resultant, no matter which method we use. So that's theta right down in this corner here. And we're going to need this angle so we can use the law of cosines, because we have two sides, and we need the angle in between those two sides. That's going to be going back to this corner over here. In a parallelogram, and I'm going to draw just a quick parallelogram out here, we know that the opposite sides are parallel. So these two sides are parallel here, and these two sides are parallel here. We know that these two angles, I'm going to mark them in blue here, this blue angle here, and this blue angle here, these are actually same side interior angles. Same side interior angles are supplementary. Means they add up to 180 degrees. So this angle here plus this angle here have to add up to be 180 degrees because they're same side interior, they're supplementary angles. That means that this angle here, let me mark it in orange here, this angle in orange here and our green marked angle over here have to add up to be 180 degrees. Well, this orange angle is just the distance between the black and the blue vectors. So we can take our blue vector, 106, and we can subtract our black vector there, 35, to give us our remaining orange vector there. So 171 degrees. That means that between these two, this orange angle, that is 71 degrees in orange there. So the green one then, the green one has to be 180 minus 71. Our 180 minus 71 gives us an angle of 109. That's 109 degrees right in here. I know this is getting a little complicated, so I'm going to skip to a new page here now. Now we only need to pick either the top triangle or the bottom triangle. This is 109, that means this angle up here will also be 109. So it doesn't matter which triangle you pick, you just have to pick one and use that one. So I'm going to skip to a new one here. And I'm going to use the bottom triangle. So first thing I need to do is redraw my vectors in. They aren't going to be exactly perfect, but they'll be close. And I'm going to draw my resultant in green, and it's always tail tip. And I know that this angle here is our theta, that's what we're going to want to find. And we know this angle here is 109 degrees. That's our R. We know the black one is 125. We know the blue one is 20. And they're both in miles per hour if you want to label them here. So if you wanted to keep your miles per hour every step of the way, that's perfectly fine. If instead you prefer to set them aside, come back to them later, that's also fine. So now we have two sides, angle between them. We can do the law of cosines first. So we're going to start law of cosines. What we have is r squared equals our first side, 20 squared, plus the second side, 125 squared, minus 2 times 20 times 125 times the cosine of the angle in between them. The angle in between them is 109 degrees. Now if you're typing this into your calculator, be aware that your calculator, your TI-83, needs to be in degrees. So make sure you click on mode, make sure you're in degrees. If you're in radians, this will give you a wrong answer. So make sure you are in degrees. What we get when we do this, we have r squared equals, and we're just typing this into a calculator right now, 17652.84077. And you can round differently. I mean, that's kind of on you. This is about where it should be. If you round to the hundredths place instead of going out that far, that's fine. You won't get that much of a different answer. So now, to get rid of the square up here, we have to square root everything, and we end up with r equals, and actually let me put this in green. We end up with r equals 132.86 miles per hour. Great. That's the first step. Now, we need to find theta as well. To do theta, we're going to use the law of sines this time around. I'm just going to do it in a different color. Law of sines says that the sine of A over side A equals the sine B over side B equals the sine C over side C. So what we're going to do is a sine of 109 over our 132.86 here equals the sine of, this time we want the sine of theta, because we want to find theta, over 125. So we do some multiplication here. We multiply both sides by 125 to get rid of it down here and get it over there. We end up having 125 times the sine of 109 divided by 132.86 equals the sine of theta, and you can either put it in parentheses or not. That's really kind of up to you. And just give me 1 second here so I can do some of the multiplication. We just do 125 sine 109 divided by 132.86, and we get 0.8896 approximately equals the sine of theta. So our next step, we need to get rid of sine. Right above the sine button on your calculator is something called sine inverse. If we take the inverse of something, it gets rid of it. So our next step, and I'm going to go right off to the side over here, so I'm going right to left, I'm sorry. but it's going to be on the left side. So we now have 0.8896 equals the sine of theta. Now what we're going to do is sine inverse of 0.8896 equals theta. If we do the sine inverse of sine, they cancel out, they go away. And we use sine inverse to find angles. So sine inverse of our answer there gives us 62.82 degrees equals theta. We're not quite done yet. And actually, let me put theta in orange here since I did all the work in orange. So we're not quite done yet. Because remember, we always want to go from north, from this direction here, 0 degrees, all the way over to this R here. That's got to be our actual heading. So we need to remember that this blue line here is actually at a heading of 106 degrees in blue. We know that our vector is not even, it's not as far as the blue one, so what we can do is we can actually take 106 and we can subtract our 62.82 that we found to get 43.18. That's going to be our heading. So here is our heading. Here is our resultant, and let me put this on a blank page here. So our final answer then would be 132.86 miles per hour at a heading of 43.18 degrees. And that's what you would box up.